So then, when you look at this and say, for system designs, what does this do for your system design, and how do you look at it? Well, if you just start with a standard, let's call it a chill water air handler VAD system, um, typically you've got big air, you've got your chillers, and you've got big air handlers that have to meet both sensible and latent loads into the space. At least they have to provide 55-degree air to VAD boxes, and then typically your VAD boxes now on the perimeters are going to be fan powered of some sort, either series and or parallel type boxes. So then you have that horsepower that you have to consider if it's series, where the the fan in each individual VAD box will be running all the time, and on the parallel type box when you're in heating configuration as first stage heat. So then when you look at it and you say a system design with a conventional type chill beam application, you start getting some more benefits, even with the traditional beams, of your chillers, your air handlers, and then your chill beams. The only difference here is with your primary secondary loop, you also have to add some more control complication, as well as some piping complication, because you typically now have to install a three-way valve to bypass that water back to the beams, because if the water is too cold actually going out there, you have to make sure it's heated up. So a lot of times the systems will either have this three-way valve in there, sometimes there's even a plate thing heat exchanger, or even a boiler induced to that piping system to make sure that that water temperature stays above the ambient dew point. So it puts a little complication in there. But the benefit you do get is you now start to reduce your outside or your primary air sources, or the air sources that are delivering your outdoor air to the spaces. But potentially they can be downsized there, but they still might have some more complicated ERV type configurations, as well as multiple stages to make sure that air is really dried out, and then sometimes you even have to reheat it back up. And then if you look at that same system, sensible only, with the new carrier induction beam units, again, in a sensible only application, which they work fine in, you do get all those benefits on the reduction in the air handler, but what you also get to do now is you don't have to worry about that three-way valve or a plate frame heat exchanger or a boiler induced into there, because if your water temperature every once in a while may get colder where you potentially can have condensation, these units have a 2-inch drain pan, and that's a dual sloped and pitched drain pan. So even if they were going to get a little water in them, they would dry out, and you have that safety there. And that's really the number one thing, going back to the IDC code there. When you think about it, a lot of that was set up to prevent liability cases, right? So if you put a drain pan in these units, you don't have to worry about it raining in the space. So from a liability standpoint, it takes that right off the table for you. And even in a sensible only, where if somebody left the door open by accident, again, you have the units, you have the protection and the safety of the drain pan in the units. So if we take it even one step further and say, okay, let's do a secondary loop with a carrier induction beam system that's also going to do latent as well as sensible. Now you get to see some more benefits here in your piping, your primary, secondary, because now you can just put your chill beams in parallel excuse me, with the air handlers. So from this point, you're running 42 or 45-degree water into your chill beam, and you're returning it back to your chillers along with your air handlers, and potentially getting a greater delta T across the whole system. And it takes out the complicated piping and control algorithms that have to be considered in the plant, now that you're just piping these right in and bringing cold water in and allowing them to do latent. Again, at that point, you would have to add some condensate capability, either gravity drain or a booster type, or gravity drain into a central pumping system. Then you can then take it even a little bit further and talk about a primary variable loop system. So now get the secondary out of there, so you reduce your install and complications in the chilled water plant by getting rid of a hydronic decoupler and secondary pumps with VFDs, just go to VFDs on a primary pump. These happen to be an example of the Carrier 23 XRVs in a series counterflow configuration, piped in parallel with both your air handlers and your new induction beams. So now your air handlers get to the point of they can almost be just a standard air handler. All they have to do is deliver outdoor air to these units. You don't have to worry about drying every bit of moisture out of there that potentially could ever happen, because now you've got chill beams that are also taking 42-degree water in or 45-degree water in, and they're designed to handle both sensible and cool and latent.
So the cost of that. I'm sorry, Mark. So the cost of that air handler. That cost of that air handler should be for that dedicated outdoor air system, where maybe in the past they want to use some sort of like a Munters type unit where we're getting the grains of moisture down to a certain level in order to handle if there was ever a certain case where the wet bulb temperature, row is raised. Now we can use a standard air handler, and it's a little cheaper. Is that correct?
Correct, because a lot of times you might even be required to use a dual energy recovery, which gets very, very costly, and also it limits you to potentially one vendor to two vendors on those types of primary air systems. Where when you start introducing this induction beam here, not only do your air handlers become smaller because you're doing less, and they even be, you're just handling the outdoor air, and let's call it neutral air at that point. But as well as the beams can now do some of the latent as well, so the air handlers might even be reduced further, and it becomes more of a common air handler. And there's, any air handler out there with a certain amount of cooling coil rows can handle 100% outside air. So
let alone the fact that also if you have a wheel in there and assume you have a certain static pressure drop, that's just adding more brake horsepower to the air system that's delivering the primary air. So in essence, we should be more efficient too, because we're not going to have the wheels for the added static pressure drop through the loss through the one or two wheels. Correct.
Correct. Especially with the dual wheels that I've seen out there. There's a lot to consider there. So correct. So that's why I'm saying you're getting more and more right down to the standard of, let's say, a standard type air handling unit versus anything custom or even semi-custom. So that's some of the benefits of using this type of beam and how it can imply on both your air side and your water side. Was there a comment?
Mark, this is Ritesh, and the other thing which I wanted to mention is when you're working with 58-degree water versus 42 or 45-degree water, just look at the number of beams required for a given zone or for the same duty or the same BTUs. Your initial cost on the beams goes down because now you can do 42, 45-degree water, so you get more cooling out of the cooling coils, and at the same time, you reduce the number of beams, installation cost, and everything in that case.
Correct. Thank you, Ritesh. You brought me right to our next slide. And what we did here is put a simple application comparison up for you and say, okay, so a typical classroom with about 28 people, primary air of 15 CFM per person, so you got total primary air of 420 CFM per the room with a room condition of 75 dry, 64 wet. And let's say the operating static pressure is about a ½ inch. So if I look at a traditional chilled beam, sensible only, at 57 degrees, and we happen to offer those, there's a Carrier units there, it would require 4 8x2 type sensible only chill beam. Now, if I take that same condition at 57 degree water and use the 36 IB, which is our new induction beam, and if I were to use a 4x4 unit, I would only need 2 in a sensible application only as well. So if you think about that, and I get the same total room capacity. If I were to use going down to our 2x2 all the way below, I'd still need the 4 and get that capacity. But if you get into, and if you look at our one-ways, I would still need 4 as well. But where it really comes into benefit is if you start saying, well, what if, because I have a drain pan, what if I design this that I can simplify my design, I can put my induction beams in parallel with my air handlers, it makes a much cleaner install of the system, and I'm running colder water at these. Now look at the number of units. So that same 4x4 unit at 45 degree water requires 1 beam versus the traditional of 4. So when you look at that, and then on the 2x2 it's 2 beams instead of the 4, and you get the same capacities, if not a little better. So when you look at that, there's a couple different things there. It reduces your install cost because you're using less beams. So that means that's less outside air connections to units that I need. It means less mechanical piping or fitter work to the beams, as well as the install. If you look at it, a standard 2x2 unit of ours weighs about 40 pounds dry. That's typically a one-man install on a ladder, and it fits right into very neatly into a 2x2 type drop ceiling scenario. When you have an 8x2 device, there's no way, no matter how light it is or how heavy it is, it would ever be a one-man install. So now, when you start comparing the man-hours on a project as well, you start looking at it and saying, well, geez, even not just my install in material and the labor of this, because I'm doing it with less units, I also need less manpower if I'm putting in these 2x2 units, because it's one person versus 2 people for everyone installed as well. So when you look at the total system install cost, it brings it down, and we've done some comparisons over a traditional air handler, chiller air handler VAV versus this, and we were actually able to do this as the value, called the VE, the value engineer of the project. And this actually came in under the budget of a VAV type system, where you think that might be the cheaper install. And that's always also been one of the barriers, I would say, to chilled beam entries in the North American market, as well as typical install cost. And now when you're looking at this, we're finding it very, very comparable, if not better, than some of our standard systems. Again, remember, you're running smaller ductwork, less ductwork, less connections, and less pipe connections. So then when you look at that application in your zone layout, to the left here you see the traditional type chilled beam, where you would need 4 of those 2x8s, and you would only need 2 2x2s if you were using 45 degree water for the same type classroom. Now the other thing I'll bring your attention to, and I'm not sure anybody sees my arrow going across my screen here, but if you look at these 2x8 units, and you look to the left of it, and to the on the units on the left, and to the right of the units on the right, you got to be very careful, because if this was installed like this, you would have stratification up the right side of your room and the left side of your room. Because remember, the air is coming out on both sides on these 2As, and then draping across and then coming back and around, and nothing's hitting those sides. So placement is also a very, very, you have to be very, very concerned with that when you're laying out a traditional chill beam job as well. And that's some of the experiences that may happen out there if you don't actually install those correctly. With an all-wave blow, as I said when we had them tested, as I said, it was 0.7 of a degree temperature difference, corner to corner, ceiling to floor. Multiple applications for these, especially when you start looking at an induction type beam and being able to handle cooler water or doing latent with the beam itself as well. It's not just typically the university labs, but now you can start looking at more education buildings, healthcare, labs, government, nursing, public library, police stations, and fire safety. Think about this. We put public library in there. You would never do a library or museum type with a traditional building, right? Where now you can do that, and it has been done. Fire stations, for example, a large fire station that would have chiller and potentially chill beams or fan coils in them. Now they open those doors. You don't have to worry about it, because you have the size to do the latent, as well as you have that drain pan. So the applications really open up to not just niche applications anymore, but into pretty much many applications. And this is just to show some examples of installs. And this is a one-way blow in a sheetrock ceiling, or the all-way in a tile ceiling to the right. I just kind of left the two down at the bottom here. If you look at the slanted ceiling off to the left, these actually have the ability to, they're collared inside, so you know, that isn't all this water running all the way down to the end of the room and out the window there. It's actually, those are, all the coils are perfectly level and straight inside that soffit there. And then you have a collar on the unit so that you can handle any type of sloped ceiling. It's standard 3 to 3.5 inch. I think that, you know, and we can make those custom if your pitches were any different than that. Also, close to an exit door, as you can see the one-way below, right above that exit door. You wouldn't do that with a traditional beam. With these, again, even in a sensible only, you could have that there, because you're going to say, well, in a school, in a K through 12, you know, maybe it's at 8 o'clock, and at lunchtime the kids are going to run in and out of that door. So you know, it's okay if it sweats a little bit because it'll dry up in there, and most of the rest of the day that door will be sealed. And then if you look further to the right, another one is high ceiling application. A traditional chill beam today would be no more than 12 foot high, and they're very clear on the specifying of that. That's an actual install using the one-ways on the perimeters, and you can see all the load from the window load there, and the all-ways 2x2s in the interior, and that's a 21-foot ceiling. So that's about where we're recommending you can go with these units. So a typical higher ceiling, also these can be installed also. So you don't have to worry too much there. Talk about some of the capacity ranges. On the 2x2 and the 4x4s, you're going total cooling capacity anywhere from 12,000 BTUs to 48,000. So on a 4x4, you can get 4 tons of capacity out of there. And you can have ventilation air of up to 450 CFM through that single unit. And your total air flows up to 1,215 CFM. And then on the one-ways, the 1x4 and the 2x4 one-ways, it's 2,000 to 16,200 CFM of total outdoor air or ventilated air, and up to 550 CFM. And so those are some of the ranges, just to give you total capacity ranges here. And typically what we see is if you're doing a project with these type beams and you go into lower water, if you use them to do latent as well, we're going to do a job with probably about half the beams that you would if you were going to design it with traditional type beams and in a traditional system of sensible only. So again, further reducing your cost of your primary air sources as well. Again, we talked about some of the noise levels of less than 35 NC, and that was tested by ETL. Again, the normal NC levels are anywhere between, let's say, 18 and 24. The 35, the less than 35 rating was up to about 1 to 1.2 inches of static, where you typically wouldn't be doing that, because if you had a beam and you needed 1 inch to 1.2 inches of static at it, would probably tell you that's not the application for that beam. You might want to put something else there. So, you know, looking at where you're going to design a beam system is anywhere between, you know, 4/10 to 8/10 of an inch. Your sound levels are going to be somewhere in the realms of the 18 to 24 levels. So even quieter, even better than less than NC 35s. As we said, the coils are rated for 410 standards of AHRI, and the total unit performance is certified by ETL. Also, some of the options that we have for drain pans, we offer a float, a trap is 3 to 3/4 inch standard, and they also come plugged. So if you do this as a sensible only, you're going to have a drain pan in there, but they'll be plugged. So if you're doing a sensible only job, you wouldn't have to worry about how you plug that drain. It's already plugged for you. And then also we provide a float with a trap and also a pressure tap is standard on each unit. And I'll give you an example of why that's important there. Is typically a balancer, when they go in on a VAV system or actually on a chill beam system, they'll poke a hole in the duct, they'll take the reading, and hopefully they'll plug that hole. Now if they don't plug that hole, with chill beams in an active start, it becomes very, very critical, because let's say, you know, you're losing 10 CFM. If you lose 10 CFM out of that little hole, you're actually losing 40 CFM at the beam inside the space. So it becomes a bigger concern. So That's why there's a tap on every unit with a cap on it, so they take the cap off, they make their reading, they hopefully put the cap back on, and you're fine. Also, just drawing your attention over to the far right picture there of the float with the trap. You know, we put that float switch in there, and that float switch is actually settable. So versus kind of that paddle switch, which tends to be unreliable, these are much more reliable, as well as they're in conformance with UL 508. But this device also allows you to set it. So let's say you're in that sensible only scenario, that application, and you do have one by an exit door, and you don't mind that it's going to drain a little bit. You know, oh boy, when that door is open, maybe we'll get an eighth of an inch or a quarter of an inch of some water in there. So I don't want to shut off the flow to this unit, right? So you can actually set that switch to where you need it to be, so that if it rises above that point, then it'll shut the valve off. Also, we offer different nozzle options, and the reason that's there is, let's say the space changes after it's been designed. So a year later, maybe you need more capacity or more airflow out of that unit. These nozzles are all, you know, they're rated for plenum rated, they're fire rated, etc. But just with a simple needle nose pliers, you can pull these out and replace it with a larger nozzle. And if you see they're kind of a triangular nozzle, that's actually to get a better sound level. With the rounder type nozzle, your sound levels get worse. So this design allows for better sound levels, as well as now I can configure a box and get more capacity out of that box just by changing the nozzles. The only reason they're different colors is really for manufacturing purposes, as part of the quality assurance, because if they were all the same color, somebody manufacturing and putting many of these in each unit, you couldn't just tell very easily by the diameter of that triangular opening. So when they're color-coded, you know the right ones are going in the right units. We also offer filter options that are throwaway, washable specials. Right now, we're up to a MERV 6, and we're testing a MERV 8 now. Should be able to release something on having a MERV 8 inside the units. Also offer special finishes on the grills. If you'd like a different style or a different finish, we can do that. We provide exterior insulation on the unit, as you can see in the picture off to the right. If you were going to use these and have, let's say, cooler than 55-degree air going through these units, they automatically then come insulated on the exterior, just as a standard practice. So in the selection program, if your entering air was at 55 or below, it would automatically default you to the insulation. We can offer different types of drain pan options. It can be stainless steel, it can be coated, it can have antimicrobial. We can do copper coils, copper coils with copper connections. You could even have a copper drain pan. Pretty much any type of special we should be able to do. Keep in mind that could vary the lead time, but again, most of those options we're more than willing to accept or take on. Again, from the energy performance standpoint, typical induction beams reduce fan power requirements by 68 to 80% of sensible load, 60 to 80% of the sensible load now being delivered by cool water. Rather than trying to transfer air all across the building, water is still the best medium for heat transfer. Pretty much it's been around forever. And again, reduced space required. The ductwork space now is smaller because you're using less ductwork and you're moving less air through that ductwork. Low noise, as we talked about in the maintenance perspective of this, we haven't even touched on yet, is there's no moving parts, so there's no maintenance to motors or things like that. Now, I will say, keep in mind, if you're going to use these to do latent as well, water across the coil will require some maintenance. But it's probably about once a year, and you can literally just vacuum it out with a shop vac type device. These coils are very, very sturdy and robust. If you press on these coils, these fins, you could not bend them. So pretty easy to clean. And then also keep in mind, even though it is condensing, it's not like a fan coil or something with a fan in it where you're going to move air and maybe potentially move dust around the space. Remember, these are coming out at velocities that are draped across the ceiling and coming down as they're trickling down through the space, and then the Coanda effects bringing up the air through that coil. So you're not bringing up a lot of dust particles and everything else that you'd be shaking up through the room like you might be doing with a fan coil or some other type of unit that would require a little more maintenance on the cooling coils. So again, maintenance is greatly reduced. Talk about your air side, your primary air source, and the reduction there, and the reduction in the complexity of that unit as well. And again, for USGBC and LEED, we've done some modeling with the Carrier hourly analysis program, and we modeled this versus an ASHRAE 90.1 type project, and using our series counterflow chillers in a typical 25-story building in Charlotte, North Carolina, using air handlers and these induction beams, it is 15 lead points. And that was being very conservative on our side, as well as reducing the energy cost by about 40% in comparison. So a lot to do there. And again, if you're installing it with condensate as well, there's things you can even do with the condensate. There's been examples for LEED-type buildings where they take that condensate and treat it, and then use that for watering a garden or for watering the plants or shrubbery of the same building, and grab some more lead points as well. So again, improving the indoor air quality. Again, the ventilation is delivered to each space and is measured. Basically, what's going into that space is what's designed for that space. Typically, in a sensible only, you would also probably over-ventilate because you're over-designing in that space, where here you don't have to. And there's only a couple methods that would ensure it. In a VAV system, you'd either have to put CO2 sensors in every space or zone, and/or have an airflow station in your air source, and it still doesn't guarantee that that's getting to the space. For this, it's in the space, and because that is the only air that's actually being introduced in these spaces. Supply air duct, again, is going to be cleaner because you're handling drier air typically, and your humidity is always controlled at 55 or less. Again, as we said, if you wanted antimicrobial, we can provide that in our drain pans. Typical installation costs that we've seen is our overall installed cost about 10% less than a VAV system. Operating costs, again, are 17% less than a VAV, and that's being very, very conservative. I think it can be even more than that depending on the size of the building. If you're introducing fan coil units as well as VAV boxes and how many there are. Again, the air balancing becomes much simpler, so from that perspective, that part of your cost of your project gets less. And if you think about also, there's a lot less electrical wiring because there's no fans now in the space. So the only electrical wiring that's going inside the actual spaces is to your lighting and not to these, except for the low voltage of a control valve that opens and closes for the unit. And again, the controls get much simpler. If you're going to design a VAV system, you're typically going to have a DDC controller in each and every unit. With a chill beam, you don't really need to do that. There's a space sensor there in the wall. You have a set point. It can either be a thermostat or it could be a DDC system with a sensor. And then you open a two-position valve, and the water will flow through that unit and maintain that space condition. So very simple control. Again, energy-efficient design. As we said, less units will do the work. Typically, it's going to be 50% less units than a traditional chill beam job. And that's using 45 and 55-degree chill water. In fact, even if it's a sensible only, some of our capacities are larger. We can still do a sensible only job with less chill beams. Again, drain pans in every unit. Units are ETL certified. We can provide you custom units and accessories if you needed different types of grills. We offer all different types of grills, perforated grills, etc. And all the coils are certified as per 410. With that, we can open it up to questions.
All right. So looks like here we had a question about, is there a sensor in the drains? And I think we addressed that or one already in your presentation. Mm-hmm. The other question was, here, let me just blow this up so I could actually see this a little bit better.
Well, let me just expand on that a little bit, too. Part of what I didn't touch on, too, is when you talk about a sensor in the drain, now, and you're shutting off the unit, even in a traditional beam system, if you're going to start to condensate, they typically have sensors that you got to have on, and it was in the system diagram of one of the first slides. you're going to have some sort of sensing device on every main branch that's going to chill beams to sense that water temp. And it's probably either going to be a strap-on sensor or an immersion type sensor into that pipe, probably a strap-on. If you think about that, if that senses anything at that point, it's going to shut the valve off. So there's two things you talk about there. Is number one, if it's sensing it there, chances are that condensate or that moisture is already getting to the beam. But number two is it's saying that, geez, the space needs that. So now you're killing off any hope of the space that it'll get what it needs. And then the unknown, or the last part of that question, is how do you recover? So, if I shut the valve off, I'm not condensating in the space, but the space has an issue because there's obviously too much latent in there, and there's more demand for cooling in there. I can't get any cooling in there. How do I ever recover that space? Because that space has got to, let's say, dry out before I can open that valve again. So it gets very hard to recover.
Okay, the next question is, per ASHRAE 170-2008 Addendum H, all condensing coils require filtration. Same goes with FGI 2010. Coils that do not condense, do not require filtration. Please address this.
Well, that's why we provide, you have the ability to put a filter in every one of these units.
We can do we can do a sensible only job, or we can do a sensible and latent project. I guess that's really, we can do whatever you want.
Correct.
Really.
Correct. That's the issue. If you're doing sensible only and you don't want to put anything there, you don't have to put anything. You could put a lint screen if you'd like. And if you're doing sensible and latent, you have the ability to put filters in.
What are you doing to prevent? Go ahead. I'm sorry.
I'm sorry, Mike. Those filters are also very easily changeable. They're just right on the grill. You can the grill is hinged on the one ways, and you can just take the grill off and insert the filter.
Okay. What are you doing to prevent mold growth with the condensate in the drains? Well, I believe we have a properly sloped drain pan, so we should never have standing water.
Correct. It's dual sloped and pitched.
And we could do an Aegon coated drain pan also, correct? Or an antimicrobial coated drain pan if you were really concerned about that.
Correct.
Plus you can drain the system or the condensate.
Okay, so we got one other one here. Would you address the cost of requiring drain pans in the installation of the tubing to handle the condensate? I'm concerned about the penetration of fire-rated walls and slabs.
Okay, and I'll probably provide a little bit, and then maybe John DeMillo can chime in a little bit. But if you think about it, you can typically do this with PVC type pipe for the condensate drain. You can do a gravity, or you can do a full condensate drain system depending on the size type building. As far as comparing those costs to, let's say, not a sensible only, or am I comparing those costs? I guess my question would be, am I comparing my cost to sensible only, or am I comparing my cost to a VAV type system?
Yeah, it doesn't state that, but I think I'm guessing it's a sensible only question, and with that, I believe one of our main answers to that is, go ahead.
Well, there's a couple answers to that, Mike. Number one is on the sensible only. Typically, you got a 2x8, so now you're doing a 2-man install per every one of the beams, and even in a sensible only, you're going to use more beams with a traditional type chill beam versus the induction beam. So right there, I'm going to have a reduction of units, so less to install, and typically a 1-man install versus two people per unit install. So then it's just a little bit added cost of running PVC.
I think this is John DeMillo from Nucleon. I think we found is that a couple things. On a sensible only job, we do not have to be drained, just like someone else doesn't have to be drained. If we are drained, We can give them up to 10 inches of height for gravity drainage, for pitch for gravity drainage. You can also put a condensate pump or run that gravity drain line to a single condensate pump, which then pumps it out from that wing or that section. In latent jobs where they have to drain us, that's generally what they do. We obviously wouldn't have the puncturing of a firewall. What we would do is run it to one single, say, larger condensate pump removal system or one central drain location and then drain from there. So you might have inside of a multi-wing building multiple locations where you have a drain line going.
Okay.
Bill Schultz here. I got a comment that might be helpful. Since we have a drain pan in our unit, that allows you to run 55 chilled water also into our coil with the use of a non-condensate system using the float switch. At that point, you have very little condensate because you could take the DOS air and dry it out a little bit, come in a little drier, so therefore you would not have to run a condensate system, use our float switch, which is the UL approved unit, and also get deeper cooling with less units.
Yeah, I mean, I think we're a fan coil unit without a fan, right? So the same standard practice you would be using for a fan coil design would be what you would be using for an induction beam design.
I believe maybe the engineer was concerned about the piping systems going from floor to floor, which then he has to penetrate that the floor rating, which could be whatever, 2-hour or 3-hour, which means he's got to put some protection around that piece of copper or whatever.
Yeah, I mean, I think when you're talking initial cost, there's definitely a initial cost add for the piping, and what we do is hopefully make up for it and more by reducing the number of chilled beams, by reducing the cost of the primary air system, by reducing the number of copper connections and duct connections because the unit number is reduced and labor overall is reduced. And so hopefully that offsets the additional cost of just running a drain line.
Yeah, correct. What you want to do is you got to look at each project and explore the whole overall project as well, because it just might also be a one-man install versus 2 men per unit also on less number of units versus the 2 to 3 hour rating penetrating through the floor in a multi. I'm assuming that we were talking about a high-rise type application or multi-floor.
Okay, the next, go ahead, I'm sorry, do you want to add something else?
Yeah, I just wanted to make one more comment. I think a lot of the engineers around the U.S. have a tendency to think that sensible is just 58-degree water. And I think they have to start thinking along that we can do a sensible design at 55. Okay?
If you actually look at coil runs at 55 or 56 degree chilled water, and you can still be sensible only, you just wouldn't have that suggestion from someone that doesn't have a drain pan.
Okay, let's move on to the next question. What is the expected life of an antimicrobial coated drain pan?
30 years.
There you go.
Okay. How high above the ceiling is the condensate outlet? Is a condensate pump typically required? I think you addressed that. Mm-hmm. And what are the best case, worst case depths of the induction units?
12 inches for a linear unit, say 15 inches for an all-way blow unit. When you start adding a collar to it, you're going to increase the height of it.
Yeah, so that's for a 4x4. That would be the worst case.
Said you, last question here is you mentioned that if you modeled it in HAP or for lead calcs, any tips for modeling in eQuest or Energy Plus?
I don't know those programs, Mike.
I don't either. So The main takeaway there is everybody needs to get HAP on the line. That's really what it is.
There you go.
All right. Okay, and I think that is it. If anybody has any further questions, you could email me directly, and I will answer those directly. But again, I appreciate the questions, and thank you guys for staying in the line with us here.
Thanks for the time.
All right.
Thank
Thank
you.
you. Take care.